This is like, does everyone know that meme, the food you have at home meme? She's like there, like, giving me sad eyes. Here, I'm gonna show you the meme I'm thinking of. Where is it? I think this is the one we are talking about. This is what's happening. This is literally what's happening. The what we have at home meme. I don't know if you're familiar with this. There's another one I'm thinking of, though. You just eat the food here. I'm sorry. Go. Go.
Painkiller.
Oh, okay, fine. 1 second. Let's give you painkiller then. Your choice. How long, Annabelle? There you go. Okay. There we go. One of those days. Okay. Let's do this. Yeah, the food at home, yes. Okay. Whew! Okay, let's change into writing mode. Let's talk about what we've been talking about. So, last class, what did we learn about? So, we've been talking about distributions of categorical variables. There are burritos. Okay. Back to this. We've been talking about the distributions of categorical variables. So the first thing we talked about was was a frequency table. So you have some variable. The example I gave was like favorite ice cream. And what you do is you look at the count of how many people were in each category. That's the frequency table, and you can turn that into a relative frequency table by dividing by the sample size. So if you can see the screen... Oh, wait. No, you can't. What happened? Oh, shoot. Okay, I'm in the wrong mode. And let me spotlight myself. There we go. Okay, does everyone see the what's it called now? The notes. Can we see them? Okay, yes. I realized I was like looking at the notes, but no one actually saw them because I was on the wrong camera. Okay, so what we have here is like last time we had I made up that we had a sample of 20 people. Let me highlight that. Here's the 20 people. You can see it right here. Okay, and the idea was, well, these 20 people, they responded with different categories. So I made up some things, like with the favorite types of ice cream, like ube, mango, pistachio, vanilla, and so on. So the frequency table is when you look at the number of responses by category. Right? So each of these here is a category. Okay, so frequency refers to the count of how many people are in that category. And I'm just putting little arrows here, so I'm showing you where you're supposed to be looking. And then I talked about how you can turn that into a relative frequency table, where instead of looking at how many people there were in each category, you look at how many people were the percentage for that category. Okay, like 15%, 25%, and so on. Okay. So we've got this. Now, the new idea that we started talking about was a contingency table, because that's for when you're dealing with two variables. So the example I gave was, what if you're looking at favorite ice cream and ethnicity? So one of them you choose as your rows, one of them you choose as your columns. So we have ethnicity as the row variable. So if you look, all the different rows are ethnicities. I have Filipino, Mexican, white, and Punjabi. Hopefully this is ringing a bell. And then my other variable, favorite ice cream, those were the columns. And you can see that you have different columns: mango, ube, cookie dough, and mint. Okay, so we have here our frequency contingency table. It tells you how many people are in the different combinations of categories. So I'm going to just choose a random number, this 7. This 7 is in the cookie dough column, and it's in the row of white people. So what that means is that there were 7 white people who liked cookie dough. Okay. So that's how you interpret the numbers, what they mean. Now, the issue was that there were 2 different ways to look at the proportions or the percentages. So let's see if people remember. Like, what were the 2 different ways to look at the proportions? And how were they different from each other? Let's see if people have it in their notes or can remember. Yes, exactly. So you would take that 7 and you would either divide it by the column total, 7 out of 9, or you would take the 7 and divide by the row total, 7 out of 10. So you have to choose ahead of time which one you're going to be looking at. Awesome. Okay. So what we're going to do today is we're going to actually go and do this in Wolfram. Like, how do you have the computer make up the contingency table for you? And I'm going to show you how to do that. So I'm going to switch the screen. So I'm going to open a new, change my window capture. Okay, you should see Wolfram now. And we're going to make a new file called contingency table. Okay, so I'm going to call this contingency table. Okay, I messed up. Contingency table. There we go. Change the zoom. There we go. Okay. Can we see my Wolfram? Is that what's showing up on the screen? Okay, good. Okay, awesome. Okay, so I'm going to start by importing the data. So I'm just going to copy in the command for that. So I'm going to paste it in. So you can see it, I'm importing the ACS, the American Community Survey data. This is like census data. And I'm calling it ACS 12. So I'm going to run that. And then I'm also going to have the computer, or Wolfram, print out some of the data so we can see what it looks like. So you can look at some of the variables. Okay, so we've seen this data set a couple different times, but you can see that we have like things like their income of the person, that what their employment status is, how many hours they've worked, what their race is, what their age is, what their gender is, whether they're a citizen, what language they speak, are they married, stuff like that. Okay, so what we're going to do is talk about, so how do you look at 2 different categorical variables at a time and make a contingency table. So let's choose some variables. Let's look at gender and marital status. So we are going to make a contingency. I hate how it does this. It always like pops down like this. Contingency table using the 2 categorical variables, gender and marriage. That's easier to read. Okay, so we're going to make the constituency table using these two variables. Okay, so usually the first step for doing this is that you're going to make, so first step is to make a frequency table for each of the variables individually. So how do you remember how to make, or actually, have I showed you how to make a frequency table for one variable? I can't recall. Do you know how to find out the different categories and how many people are in the different categories for, say, just the gender variable or the marriage variable? I feel like it's been a while with the 4-day weekend. Did we talk about this last time? Yeah, it was a while ago, probably. Okay, so let's remind ourselves. So what you do is you take your data. So I'll put ACS12 and I'll say, let's take all the rows. I want the gender variable, // and then what's the command to have it figure out how many people are in each category. Do you remember? It's counts. Okay. So it counts. There were 969 females in our data set, 1,031 males in the data set. Okay, let's do the same thing for the marriage variable. So all I did is copy and paste that, and I'm going to replace gender here with marriage. Oh, married is the variable, not marriage. Let's change that. Okay, so apparently, looking at the married variable, 833 of the people were married, 1,167 of the people were not married. Okay. Okay, so this just gives you a breakdown of the variables individually. Okay, now what we're interested in doing is looking at the interactions between the variable, like how many females are married or not married. See, if you look at the married variable, it only shows you whether someone's married or not. It doesn't tell you if they're married and they're a woman, or if they're married and they're a man. So to take into account both of the variables, let me show you how to do this. So how do you make the step to a contingency table? Okay. So what you're going to do is use the map command. Daphne, can you take burrito out, please?
Okay.
Thank you. Okay, so you're going to use the map command. And there's going to be a lot of different things that are going to go into it. So when you use the map command, you have to put the brackets. I recommend you do some open space. Okay, so there's 3 things that you have to tell the map command. You have to give it a command. You have to tell it what data to use the command on. And then you have to give it a number. This right here? You don't need to have a space there, actually. I just accidentally put it. Okay. So the command that you're going to be using is the counts command. Okay, now the data is going to be the two variables that you want to use. But it's slightly more complicated than that. So you would think that you'd say ACS12, all, comma, curly brackets, gender, and married, but not quite. And the reason you can't just do this is because you need to specify which is the row variable and which is the column variable. So when you tell Wolfram what data to use, oops, okay, I don't know why it keeps doing that. You have to specify which is the row variable and which is, why does it do that? Okay, I start typing and it just keeps on jumping down. You have to specify which is the row variable and which is the column variable, and I'm going to show you how to do that. Okay. You specify the row variable by telling Wolfram to group by that variable. So which one would you like as the row variable? The gender or married? Like which one would be the rows? You choose. Someone choose for us. Which one? Cool. So gender will be our row variable. So what you do is before the all, you put group by brackets, and inside there you put gender. So we're not going to have gender over here. So what that's telling Wolfram is, yes, there are two variables, but the gender is how you're going to group everything. That's what it calls the rows, basically. So gender is going to be the rows, and then it sees the other variable, it knows that those are going to be the columns. Okay, then you put a comma at the end of that. Okay, on the last line you put a number. The number is the number of group bys. The number of variables in the group by. So because I have one variable in the group by, we put the 1 there. So I'm going to run that. And you get this. Here is our contingency table. And now you can see, well, if you look at just women, how many women were not married? 583. How many women were married? 386. So I'm going to pause for a moment. So what would you need to do if you wanted to switch the rows and columns? But transpose what? That is the proper word. You're actually thinking too far ahead. What would you do specifically in this command here that I'm highlighting to get the rows and columns to change? Like, what if I wanted to have the row variable be married? What would I need to do? Yes, exactly. You would just switch them. And if you run it again after you do that, you can see now that it looks at the rows by people who are not married, right? So you're like, oh, of the people who are not married, 583 of them are female. Of the people who are not married, how many of them are male? So it's arbitrary how you do it, but usually we read everything by the rows. So you look at this and you're like, oh, I'm looking at the group of people who are not married, 583 of them are female. Okay. Let's change it back to the other way. Cool. So I've showed you how to make it. I've showed you how to calculate it. Now what we're going to do is visualize it. So some people prefer to work with graphs as opposed to numbers. So I want to show you how to take these frequency tables and turn them into pictures, basically. Oh yeah, sure. Well, so you always need to. It's your choice always, unless it's specified what's your row variable and what's your column variable. So what I'm going to do is I'm going to copy that command. I'm going to paste it right underneath here. Okay, so we're going to look at them at the same time, but we're going to switch them. So do you see how it's literally the same command, but just what's in the group by is switched? Cool, so I'm going to run it. And now you can see, like, it's the same command, but, like, what's a row and what's a column is changed. It's not like one is more important than the other. The numbers mean the same thing. It's just how you read it is different. So what I was pointing out was that you always read it by the rows. So if you look at the top command, you say, oh, I'm dealing with females, because there's a row of females. How many females are not married? 583. But if you look at the one below, you read it by rows, so you're saying, oh, I'm looking at people who are not married. Of the people who are not married, how many of them are female? 583. Okay, so there's like a way, an order to read it. You first read it by what row it's in, and then you read it by what column it's in. Does that make sense to everyone? Like, you can switch it, then you need to properly say it. Let's take account for that. Okay, so let's talk about the graphs. So let's say that you're looking at how many people, the marriage status of people. Okay, so you're looking at this, and which group is the larger of the two groups? If you look at marriage status. Yeah, there are more people who are not married compared to people who are married. And you can just see that the number is larger. But sometimes it's useful to turn this into a graph, because it gives you a better way to see like how much bigger one group is compared to the other. So what you can do is, after the counts, you can say, turn this into a bar chart. So you put another / bar chart. And what's cool about it now, or what's interesting about this, is that these two little boxes, they are the different groups. So if I hover over this box, you see how it's 1167? That was the number of people who were not married. Let's just put that back up there. Okay, so you see it says 1167 on the one on the left, and then if I put my mouse over the one on the right, it says 833. Okay, so people sometimes like to look at this because it gives you an idea. Is the larger one like twice as big as the other one? Is it like way bigger? Are they roughly the same size? Okay, so it gives you an idea of like the relative size between the two groups. We could do the same thing with gender. Let's just replace the gender variable here. Okay, there are slightly more men. There's 1,031 men, and there's 969 females. But now looking at the bar chart here, you can see that the groups are basically roughly the same size, right? You see how it's just like a small percentage difference? Okay, so sometimes if your number sense is not very good, the chart helps. So let's talk about that. So some people prefer to work with graphs as opposed to numbers. The graphs are very useful for comparing relative size of the groups. i.e. is one twice as large as the other, or are they roughly the same size? Questions about the graphs so far or making them? I'm going to pause for a moment. We're good so far. Let me get some reactions with people. Just need to know. Does that make sense? No. Yes, no. I'm gonna pause. It's good so far. Okay. Just gonna give people a moment to think. Yeah, no, that's why I'm pausing. I figure people are taking notes, so I was like, I should probably just stop for a second. Yeah, no problem. And then I'm trying to find my next example that I want to do. Yeah, it's streaming. It's going to YouTube right now. So yeah, it will be there. I'm waiting. I'm looking for the next thing that I wanted to do. I'm just having a hard time finding it. mess around to see if I can get the one that I want to work this way. Type it in. Let's see if this works. Okay, that did not work. Trying to leave that there. Okay, is this gonna work? Okay, it's not. Scroll down. Okay, I'm having, just give me a moment. It's supposed to make a different type of graph. Why is it not working? Okay, maybe this won't work. Okay, this is not working for me. I'm sorry, I'm like looking for why it's not giving me what I want to do. Like when I plugged this in earlier, it worked, and I'm not sure what I'm doing wrong. Just give me a moment, sorry. This is like the problem with technology. You're trying to do something and then like you want to do something else and then you're like, oh no, this is not working. Okay, I don't think I'm gonna figure this out right now. I'm not sure what's wrong. I guess I'll just move on to another thing. I'm sorry. I'll come back to this. I'm like entering the command wrong. It's like showing up the wrong way, and I'm like looking in my notes, but it's like not working the right way. So I'm gonna come back to this. For now, you know how to do the bar chart. For some reason, it's not working for the two variables. So let me see what else we needed to do today. Oh, there is one thing I want to talk about. Okay, let me paste this in here. Okay, perhaps you guys have heard of a pie chart. Does this look familiar? The pie chart? The pie chart and the bar chart show you the same image, but you should not use the pie chart, and I'm gonna show you why. It's because the pie chart is actually sort of hard to read. There's a bunch of weird disadvantages to it, and you can only really notice it when you find a variable that has multiple categories. So let's see the race variable. Okay, here. So race has 4 different races in the census data. There's white people, other people, Asian people, and black people. I guess there's only the 4 races in this data. So if you go and you do the race for bar chart, you actually can look at them, and what do you notice right away about all of the groups compared to white people? They're all what? Yeah, cool. So they're all small. Like, there's a lot of white people, there's barely any others, Asians or blacks. And what you notice is about, when you look at them, you can see that the 206, there are more black people than Asian people and other people. And that, like, really comes across in the bar chart. But if you look at the pie chart, it's usually a little harder to tell, like, which is the large. Like, you can sort of tell here that the blue one, whatever that is bigger than the other groups. But then it becomes sort of difficult to, like, relatively compare the sizes of the 3 smaller ones. So it's highly recommended that you just use the bar chart as opposed to the pie chart. And we're going to get into it today. I don't know, someone's knocking on my door. I think it's the plumbers. And my dog is going crazy, so we're going to just have a little party today. I'm going to look up the example. Okay. I think I'm just having one of those days. I'm going to figure out what went wrong with my pie chart thing. We're going to end early. So I'm going to leave this up. 15 minutes early, we shall end. I will come back tomorrow with the worked out example of the other thing. So please, before you go, put I was here.